In this video, I'm building a fixed-wing cargo UAV platform. I built a lot of RC planes and UAVs in the past, but I've always wanted to make a proper cargo aircraft that can drop things and carry all sorts of different experiments and payloads, so I finally decided to build one. Step 1 was to choose a type of wing. There are 3 main types of wings: rectangular, tapered, and rounded ones. The rectangular wing is used on trainers and light aircraft for simplicity and good performance, because it's simple to design and build, as we only need to make one straight cut. It also has good low-speed performance and gentle stall characteristics. A stall happens when the airflow separates from an airfoil, which causes the airfoil to lose its lift, which is not good for an aircraft. In rectangular wings, the stall starts from the root, which means that we have plenty of time to react, because the ailerons remain effective when we need them the most, and the stall isn't aggressive. But rectangular wings are less efficient than tapered and rounded wings. For this plane, I went with a square wing in a twin boom configuration, because of how easy it is to build, and because of its good load distribution and predictable stall behavior. I went with the popular Clark Y airfoil, because it has gentle stall characteristics and good lift at low speeds, which is perfect for a stable, slow-flying cargo platform like this. It's also flat on the bottom, which makes it way easier to build, as well as mount the fuselage and tail booms onto. With 2 motors mounted on the wings and the fuselage mounted right under the wing to carry the payload, you get a stable, easy to control cargo plane built to lift and drop loads safely. Compromising a bit of efficiency for better handling, more reliability, and much easier assembly is totally worth it for what this plane is meant to do. For building the aircraft, I used this 50mm closed cell XPS insulation foam panel, which I first cut into pieces using my handheld hot-wire foam cutter. I had to do all of the cutting outdoors, because the fumes from the cutting may cause lung cancer. I then used my CNC hot-wire cutter to cut out the airfoils precisely. Because the hot-wire cutter is so small, I had to cut out the wings in segments that I will later glue together. At some point, I might build a larger version of this machine, so I could cut larger wings more easily, but for now, I'll be using this one, as it's good enough for this purpose. After cutting all of the wing segments and foam pieces for the fuselage, the wing pieces were still inside of the foam blocks, like this, so I had to remove them. This part of the process is really satisfying, as they all come out so easily, and the result is almost always perfect. It almost feels like it's Christmas, because there's so much to unbox. Cutting these parts out with the CNC hot-wire cutter also means that it's really easy to cut out the control surfaces and spar holes, which saves us a ton of time of not having to do it by hand. For the wings, I'll use a 1 meter carbon fiber spar to reinforce the wing. These carbon fiber spars are great because they're really strong, but really lightweight and slightly flexible. Then I glued the segments together using hot glue. Hot glue is ideal for this purpose because it melts the foam and fuses it together, creating a really strong bond. It's also easy to apply and really cheap. You just have to be careful not to burn yourself, which has happened to me a couple of times during this build. After assembling the main wing, I also assembled the horizontal stabilizer. I added these carbon fiber rods into the foam to make it more stiff and durable, so it wouldn't hopefully start oscillating during flight, which wouldn't be very good. I then cut out the foam pieces for the fuselage, after which I assembled them together. I had to make sure that I glued them precisely in the correct angle, so that the fuselage would be the correct shape. Then I sanded the fuselage with some 50 grit sandpaper, just to make the corners round. To make the fuselage, I could have used my CNC foam milling machine, but I came to the conclusion that making it by hand was far quicker for this type of fuselage. Then I prepared all of the parts and cut out the slots for the servo motors like this. After I had prepared all of the parts, I laminated them with this plastic heat shrink film. And I used this hot iron, which basically activates the glue underneath the plastic and attaches it to the foam and then shrinks it to create a smooth surface finish. I covered everything with this shrink film because after trying out other methods in the past, such as fiberglass and epoxy, I have come to the conclusion that this is the most durable and lightweight, yet cheapest and nicest looking solution. Together with the XPS foam underneath, it forms a really strong structure. Then I 3D printed all of the other parts I needed for the aircraft out of PETG filament, as they had to be strong. After that, I assembled the tail assembly and then glued these carbon fiber pipe tail booms to it. Then I installed the motor mounts to the wings, and I burned my finger in here. And then the tail booms just go into there like that, and then everything's screwed together. For this plane, I'll be using these 2212 Brussels DC RC plane motors, which will be powered by these 30 ampere ESCs. And then the motors simply screw onto the motor mounts like this. Then I installed all of the other electronics to the plane, and I was able to cover up the wiring neatly like that. In this plane, I'll be using the Maytag F405 Wing V2 flight controller, as well as this M10Q GNSS and compass module. These are actually the same components that I was using in my RC boot video, and surprisingly, after putting them in rice and drying them out completely, I somehow managed to get them working without any issues, and they were as good as new. Then I installed everything in the fuselage, and for the RC receiver, I'll be using this ES900RX Express LRS receiver, working on 868 MHz, which has really good range. And for the FPV video transmitter system, I'm using this 600mW 5.8 GHz one, together with this FPV camera, as I had them lying around. For the battery, I'm using this 6000 mAh 3S lithium polymer battery. I could use a lithium ion one, which has a higher energy density, but this one will do for now. And I had to add this NEMA 17 stepper motor into the front for the correct CG. I also decided to add some landing gear, as I had some lying around. I had to make some mounts for them, so I 3D printed this part and then put some heat insert threaded brass nuts in there by pressing them down with the soldering iron, which melts the plastic and keeps them in place really strongly. And I think it turned out quite good. And then I just attached the landing gear to it with some machine screws. Then I connected the control surfaces to the servo motors. To hold the wings in place, I used these big rubber bands, which are stretched across the wing and are connected to a thick carbon fiber rod, which is attached to the fuselage. The mass of the plane is around 2.5 kilograms, and I'm using these 9045 9-inch propellers, which are not the most efficient propellers, but I just happened to have them, so I went with them, as they'll still work almost as well, and provide around 15 newtons of thrust combined. Then I went outside to confirm that the system works correctly, and see how it rolls on the ground. Everything seemed to be working, and the steering worked really well, with the motors providing more than enough thrust for takeoff. And it didn't tip over either, which meant that I was now ready to go see how it flies, if it can fly. So unfortunately, it snowed here last night, as you can see, so I probably can't use these wheels to take off. But I've cleared a little runway right there, so I probably can land with these wheels just fine. And the weather's really nice out here. It's really calm, and it's not really cold, although it's like -5 Celsius right here. And it's a bit sunny. The sun is going down, so I have to be a bit quick. And I added this camera right here, so we'll probably get some nice video from it. But yeah, let's get everything set up. So I also added this cellular GPS tracker, which sends the GPS location with 4G to my phone. So if I lose this plane, I'll be able to recover it and find it. But yeah, let's get is plugged in right here. So I've now got everything set up, and for FPV I'm using this monitor right here, mounted on this tripod with these antennas, so hopefully we'll get some nice video from it. 3, 2, 1. Perkele! So that didn't quite work. I think it was a bit nose heavy, because it tried to take off, but it just wasn't able to pull up properly. The only things that broke were these connectors, which kept the tail on. I'll have to improve these at home and reattach the tail. And the nose wheel also seems to have bent a little bit, but it's an easy fix. I'll probably head home and repair this, and then try again tomorrow. While trying to figure out what went wrong, I noticed the thick layer of frost on the wing, and in aircraft, icing affects everything that makes them fly. Even a thin, sandpaper-like layer of frost can slightly reduce lift and increase drag by disrupting airflow, and can also slightly reduce propeller thrust. On this day, there was a lot of frost in the air, which accumulated onto the aircraft while I was setting everything up. For RC planes and drones, the detrimental effects of frost and icing is much more noticeable due to the low Reynolds numbers and more sensitive aerodynamics. I suspect that this crash was a result of both the frost as well as the aircraft being slightly too nose heavy. I also noticed that the elevator had basically no pitch authority due to its initial tuning settings, which was likely the main cause of the crash, so I fixed that. I decided to remove the landing gear altogether, because the front landing gear had bent, and repairing it would have taken some time, and I couldn't properly use the landing gear in the winter regardless, so the quickest solution was just to remove the landing gear. Removing the landing gear also reduces the aircraft's drag, and reduces its mass by around 250 grams, which should further make takeoff easier, and allow for a heavier payload. I can also reattach them later if I want to. During the first test flight, the CG was conservatively set too far forward at 63mm instead of the 70mm predicted by CFD. This forward shift, combined with the steep pitch moment curve, made the plane nearly unable to fly. I shifted the CG back to 70mm, which is the trim point, by moving the heavy stepper motor back by around 4cm. I also added some skids to ensure level landings and to protect the fuselage and tail. Oh, it actually flies! Holy shit! I didn't expect this. I think I'll probably auto-tune it right now. Now that I got some altitude. Let's see how it goes. Hopefully it doesn't crash. It seems to handle it fine. I think I'll put it into return to home mode. Like this. It seems to be doing something. It's flying by itself right now. And everything looks really good here. It's more efficient than I thought. I didn't expect it to fly this good. Compared to my last phone, I can zoom really well with this one. So there's a significant improvement in the video quality. I've set it to fly at 50 meters, because the altitude limit here is 50 meters because of the close by airport. But there's this ridge right here, which is I estimate to be around 50 meters, which means that technically we can fly above ground here, 100 meters high. Okay, I think I'll bring it in for a landing. It's a bit high up, but I think we'll do pretty good. I think I'll have to do another pass because it's really high up. That wasn't too smooth, but it worked. Is it still in one piece? It seems to be fine. I can't believe this actually worked. So, this project was a success. In a future video, I'm planning to come up with more fun things to do with the plane. Thanks for watching this video, and if you haven't subscribed yet, make sure to do so, in order to not miss any of my other future projects. Meow!